In this video, we'll investigate the use of vehicles from the standard library. And so what we're going to do is we're going to start with a base model, and you can see that we have a source, two servers, and a sink, and the processing characteristics are as follows. We have exponentially distributed inter-arrival times of 1 minute, and service times at both servers are the same, triangular 1.75, 2.25. And so if we look at the arrival rate and service rate, we expect our base system to be stable. We have entities arriving at the rate of 60 per hour, and we can process at an overall rate of about 68.6 entities per hour. And in our base model, we just left the default selection weights between the two paths as 1, so 50% of the entities are going to go this way and 50% are going to go this way. And what we're going to do during the video is we're going to incorporate the use of vehicles to transport the parts between the source and the individual servers, and then from the server to the sink. So let's look at our base model. Here we go. As I said, the processing characteristics, we have exponential 1 minute in arrival times, and we have triangular 1.7, or excuse me, 1.75, 2.25, also in minutes for server 1 and server 2, and we've left the default selection weights as 1 and 1. So the first thing we're going to do, let me turn off the visibility of the arrows, and then we can run the model, and we can just sort of watch the model execute and make sure that it does behave as we expect. So what we expect to happen is about half the entities to go to server 1 and half to go to server 2, and overall we should expect the system to be able to keep up. So I can increase the speed factor, and we can just observe for a little while, and certainly the system seems to be behaving as we expect it to. So let me get back down, change the server, the speed factor back down, and let's go in now and look at how to incorporate vehicles into our model. So the first thing we're going to do is place a vehicle object instance from the standard library in the facility view. And we can see that we have several different properties for our vehicle, and we're going to look at some of these properties during the video. But what we want to do first is change the initial desired speed. So the default speed for our vehicle is 2 meters per second, and we're just going to change that to 1 meter per second so that our vehicle travels a little bit slower. And the other thing that we're going to do is we're going to set what's called the initial node, or the home location for the vehicle. So when we run the model and we create run spaces of the vehicle, they have a home node where they will initially reside, and then we can control how they go back to the home node or stay in their current location while the model is executing. So I'm going to select the initial home location as the output to source 1. And so now we've defined our vehicle, we've set its initial desired speed, and we've defined its home location to be the output of node 1. So I'm going to reduce the speed factor just a little bit, and I'm going to run the model. And we see what happens is when the first entity arrived, the vehicle transported that entity to server 2, and then we could see, if we watch carefully, we could see the entity after it completed processing went to the sink. And now it looks like the entities are queuing up outside source 1, and the reason is because we have specified that the entities need to ride on a transporter, on a vehicle, and there's no way for the vehicle to get back to the source node. As we see here, the vehicle is sitting in the parking queue, the parking station for server 2, but it has no way to get back. So in our network, there's no path that the vehicle can take back to source 1. So there are two things here that are important. First of all, vehicles by default do not enter objects, and so when the vehicle came to the input node, the part or the entity unloaded from the vehicle was processed and then continued, but the vehicle does not go through the server. So what we need to do is add some additional paths for the vehicle to take. So what I'm going to do is I'm going to put a spur around server 2, similarly a spur around server 1, And then finally, I'm going to put a back path from sync 1 back to the source to provide a way for the vehicle to get back. And so now when we run, we can see the vehicle drop the first entity off, just like it did before. And now when the second entity arrives, the vehicle goes around the spur and then back to the source to pick up the next vehicle. So we'll just let this run for a little while and watch the general behavior. You can see one thing that's happening is that we haven't done yet is we haven't specified that the vehicle picks up entities from the output of server 1 and server 2. So for example, when the entity just finished at server 1, it goes automatically to the sink. So we can change that behavior just as we did earlier by selecting both of the output nodes, which I did using multi-select, and then setting those right on transporter values also to true and use the vehicle. One more thing that I'm going to do really quickly after I do that is select the two paths that leading from the server to the sink and make those bidirectional. By making those bidirectional, it will let the vehicle go from the sink directly back to the server if it has to pick up entities that are waiting in the output node of the server. So we run for a little bit and we can watch the model. And let's speed this up just a little bit. We'll speed it up to 2 here and just watch the model execute. And you can see that the entities are being transported between both of the locations from the source and the server, and then from the individual server back to the sink. And so you can see now I've let the model run for a while, and we see entities queuing up in the output queues or the output stations for the source, server 1, and server 2 also. So it seems that we don't have enough vehicle capacity, at least initially it looks that way, that we don't have enough vehicle capacity to support our system. So what we're going to do is we're going to look at 3 different ways that we can increase that capacity. The first thing that we're going to do is we're simply going to select our vehicle and change the initial ride capacity. So the initial ride capacity specifies how many entities can be riding simultaneously on the vehicle. So I just changed that from 1 to 2, and that's saying that 2 vehicles can ride on the transporter. So you can see that happening here when when 2 entities are ready to be transported to the same place. The vehicle will in fact pick up both of them. Note at the source it won't always pick up 2 because sometimes the entities are going to server 1 and sometimes they're going to server 2. But when we have multiple entities in the outputs of server 1 and server 2, the vehicle will always pick up multiple entities. So that's the first way that we can increase the capacity of the transport system of the vehicles is by simply increasing the ride capacity. The second thing that we can do is we can, let me change this back to 1, and we can use the population parameter to create additional copies of the vehicle. So the vehicle object is a dynamic object, and so we can create multiple copies. And so I will just change the initial number in system in the population to 2, and now when I run you can see that we have 2 separate run spaces of the vehicle 1 object instance, and so they at their default can only transport 1 at a time, 1 entity at a time. And so instead of having capacity 2, now we have capacity 1 but 2 separate vehicles. Note that we could also combine those methods and have ride capacity of 2 and still have 2 vehicle or 2 members of the population. And so in this case we have total ride capacity of 4 spread between our 2 vehicles. So if we increase the speed factor a little bit and let that run, we can see now, at least initially, it looks like our vehicle capacity is sufficient to keep up and the system will continue running. So when we use this method, let me pause and let me actually stop the model, go back and change our initial ride capacity. When we use the population, we've created two run spaces. So these are two run spaces of the identical vehicle. And so when we set the capacity of the vehicle, the initial capacity of the vehicle, it's the same for all of the run spaces. So the third way that we could handle this is, let me go back and change this to population 1, is to create a second vehicle instance. So I can grab a second vehicle instance. So now I have vehicle 1 and vehicle 2, and we'll change vehicle 2's color so that it looks a little bit different. There we go. So now we have a red vehicle and a blue vehicle. And we can specify the vehicle to use for each one of the transports. So we did that earlier. We have a specific vehicle, vehicle 1. So for example, we could go over and say, I only want the red vehicles to transport from the end of the servers to the sink, and I want the blue vehicles to focus on the transportation from the source to the server. So we can do that easily by specifying which vehicle to use at each node. An alternative is what we have seen before, is we could use a list. So I can go to the model definitions, create a list, and now what I want is a transporter list. We'll just leave the default name of transporter list 1, and then I'll go and add vehicle 1 and vehicle 2 to my transporter list. So now I've created a list of the two transporters, and I'll go back and choose all three of my output nodes and change the transporter logic from specific to select from list. And so then I will specify my transporter list 1, and then there are a variety of methods we can use to select from the list, exactly what we've seen before. And so now when I run, we have a list of vehicles. Both vehicles are in the list, and we can the system will select which one to use. Now in this case we can change the vehicles, so I can have vehicle 1 have initial ride capacity 1, vehicle 2 have initial ride capacity 2. So let's say it can carry 2, but it moves slower. So we will recall vehicle 1 moved at 1 meter per second. We'll change vehicle 2 to 0.75. So it has more capacity, but it moves slower. So we can also mix and match the methods that we chose to select the vehicles. So we changed all of the nodes to select transporter from list, but I could also select one particular one and say, okay, I want a specific vehicle just for this move. So the move from output to server 1 to the sink, I always want to use the red vehicle or vehicle 2. And so for the other output nodes, I've selected from the list, but from this one, I've selected a specific vehicle. And so you can use these various methods of vehicles by increasing the population, by setting the ride capacity, and by selecting the method that you use to select the vehicle to construct fairly complex and robust vehicle systems for your models. There are many other options that we see with vehicles in terms of load and unload time, so we can set stochastic or deterministic times for the vehicle to load unload. We have a dwell time, we have different routing logic, and so I would encourage you to experiment with these, and then we'll use some of these when we come back to the subsequent video.